So what we're going to be talking about today is linear regression and correlation. Now these are two things that you should have done in 9th grade, so it should be review. Okie dokie. Okay. All right, so second page. How many fast food hamburgers do you eat in a week? You're going to put your answer in there. If it's 0, great. If it's 1, okay. If it's any more than 1, I'm probably concerned about your health. You probably eat more pizza than you do burgers, right? Yeah. Okay. We had pizza last night? Yeah. Some of you have it every single day for lunch, right? Okay, next page. How do you think the number of grams of fat and the number of calories in a fast food hamburger are related? The more the related in terms of fat and calories. What do you think happens? The more fat, the higher the calories. Okay. Anybody else agree, disagree? Positive correlation, is that what you just said? I like you. Directly related. Very nice. Okay, big words today. Okay, so we're thinking they're probably directly related and it probably has a positive correlation. I like both of those things. Is this okay? correlation. Okay, so they're directly related. They probably have a positive correlation. I'm sorry, I do have a spelling error in here. Okay. So on the next page, you'll find a table showing the number of calories, and that should say number, not nuber. Number, oh, that's not the right letter. Number. Oh, why? Number of grams of fat for different types of hamburgers from 3 different fast food restaurants. So this is actual data, okay, from actual fast food restaurants. Yeah. All right, so fat. Calories from fat is 11 grams. Calories from fat would be 270. 15, 320. 9, 270. 19, 360. 13, 320. Look at all this data. Ooh, 28, 450. 26 grams of fat. 530 calories. Now, why would some of this data vary? From different restaurants, yeah, different methods of cooking, different toppings, all of those things could play a role. Yeah, burgers. So it could be one is using mayonnaise where the other is using ketchup, or maybe they just have a really fattening mayonnaise and the other one has a light mayonnaise. Maybe the calories are the same, but the fat content is different. So all of those things can make the data vary. But what we do notice is as fat increases, what happens to calories? Generally, it increases, right? Okay. So on the next page, we're going to put a scatter plot. You guys have dealt with scatter plots before, right? Okay, from this scatter plot, we're going to determine what our domain values were and what our range values were. Domain, again, is what values? X, and in our case, it's fat. And our range would be Y or calories. Okay, good. So, we're going to go to the next page. Now, right now, all the data values are just thrown on there. It looks like somebody threw up on the screen, right? What do I have to do in order to make it appropriate for my data? Good, I have to click and add my variables, right? So down below where my domain is, that's going to be what? Fat, very good. So click, select fat, and all my data values are going to move. All right, here? Good, so we have to click up here and select calories, and then we get this beautiful scatter plot. Okay, so I thought my refrigerator was making funny noises, but it's Alka-Seltzer. Okay, so we've got this really nice scatter plot. Does it look like it has a positive relationship or a negative relationship? Looks like it's positive. If I were to put a line in there, would it have a positive slope or a negative slope? Positive. Okay, so everything's leaning towards positive, right? Does it look like I could put a line in there? Yeah, so you guys talked about that as being called the line of best fit, right? The line of best fit is nice, but with the line of best fit, when you put it in there yourself, you get this kind of human error issue, right? It's not going to be perfect. Our calculator does something called a linear regression, or there's many different kinds of regression. We would use linear because this looks like we could use a line, right? So linear regression is going to give us the best equation that fits this data, okay? So how do you think I insert a linear regression? Menu, very good. What are we doing to the graph? We are analyzing it, very good. And we want a regression and show linear. The mx plus b is what we use for math. Ax plus b is generally used in science, okay? M is slope, yeah. It's slope-intercept form, right? So we get this equation. Okay, so this is our linear regression. And again, it's the best equation that's going to fit this data. Are you okay with that? And sometimes what will happen is the equation will get like off the screen and you'll need to see more of it. And you can always grab and move it to another location if that's the problem. In this case, I think it's okay, but just keep that in mind for later. Are we good? I made it go away. There it is. Okay, so why does it make sense that the number of grams of fat is used as the independent variable? Independent meaning what? It stays the same, right? It's not going to be changed based on the other variable, right? Which ones are independent? Are fat. So why is calories dependent? It changes according to how much fat I have, right? So it makes sense that fat is the independent because that's that determines how many calories it's going to have. Okay, calories, do you guys know what calories mean? Yeah, it deals with energy, how much energy it takes to break something down. That's how calories are represented. Okay? Correct. Yeah, and X, your domain will always be the independent, and your range will always be the dependent. Okay? Okay, so what is the equation for your line of best fit? And you're going to type it in. I put it up on the board for you so it's easier to see, so you don't have to flip-flop back and forth. Are we okay? Okay, so based on the regression equation, how many calories would a hamburger have if it had 22 grams of fat? How could I figure that out? Yeah, put 22 in for X, right? Because X is what? It's our independent, so it's fat, right? Okay, so how do I put that in? What can I do? Yeah, awesome, store. Okay, oh, my board is not playing nicely. X store 22. And then you're going to put in your equation. 12.1432 X plus 156.787 and enter. Okay, so 424 approximately calories. Okay. Questions, concerns, problems? Good? All right, y'all have this bored look on your faces because you already know how to do this. It makes me a little happy, to be honest. Ready? Okay, so what does the y-intercept mean in the context of the problem? Y-intercept, right? Okay, so y-intercept maybe the graph looks something like this. This would be your y-intercept. What does that value mean? This is fat. This is calories. Good. It's how many calories you have if you have 0 fat. Because even if you don't have any fat, you still have to have calories, right? Everything has calories too because it takes energy to break down. Okay, good. So how many calories you have when you have 0 fat is your answer. Okay, so based on the regression equation, how many grams of fat would predict a 1,243 calorie hamburger? So how do I do this one? Yeah, I gotta plug 1243 in for y, right? So 1243 equals 12.1432x plus 156.787. So how would I solve that? How do I solve for x? Good. Subtract 156.787. Okay. Good. And divide. So it's, yes, which I was just about to talk about. Okay, hold on. You typed it in wrong. I typed it wrong. Then you both typed it wrong. I think mine's right. Maybe just typed a number in wrong, perhaps. Okay, so the other option is numeric solve. Now, did you guys learn how to use numeric solve last year or the year before? You're going to want to know how to do this. Ready? Menu. Algebra. Numerical solve. You type in your equation. 1243 equals 12.1432x plus 156.787. Right, I have to tell the calculator what to solve for. So comma x inside the parentheses, okay? Everything's inside the parentheses. Hit enter, and you get your answer. Will this work for any kind of equation you give it? So will it work for rational equations? What we've just been doing, right? So it's a nice way to check your work to make sure that you're right. It's only going to give you one of the answers. If there's more than one answer, you got to find it. But it'll only give you one, okay? Are we okay? Okay. So which of these statements is true about the relationship between the number of grams of fat and the number of calories? B, yeah, the number of fat increases, the number of calories increases. Good. We doing okay? And again, that's a positive relationship, right? Or a positive correlation, which is what we're going to talk about now. All right, so for situations in which one variable increases in value and the other variable increases, we say that's a positive correlation, right? For instances where you have values decreasing and the other value is also decreasing, that's also a positive relationship or a positive correlation. So the way you can think about this is multiplying signs. So what's a positive times a positive? Positive. What's a negative times a negative? Positive. Okay. What's a positive times a negative? And a negative times a positive? Negative. Okay, so if one's decreasing and one's increasing, that's a negative correlation. If one is increasing and the other is decreasing, it's also a negative correlation. All right, so think of it like signs. You can handle that? Okay. So if a relationship between a number of grams of fat and the number of calories is positive or negative, what is it? Positive. We've said that about 8 million times now, right? Okay, so it's a positive relationship. All right, so I want to talk about one more thing, and you're going to have to put this in your notebook because it's not in your calculator. I want to do a little refresher of correlation from 9th grade. Who remembers what variable we used for correlation coefficient? It's not what you would think it would be. Anybody remember? We use R. R would be our correlation coefficient. Does anybody know what two values the correlation coefficient can be between? You guys don't remember correlation coefficient, do you? No. Glad we're going over it. Okay, correlation coefficient can be between 1 and -1. Okay? What the correlation coefficient describes is how strong or weak the relationship between two variables is. The closer you are to a positive one, the stronger the positive correlation. The closer you are to a -1, the closer you are to a strong negative correlation. The closer you are to 0, the weaker the correlation altogether. Okay, so let's see what that looks like. I'm going to draw a couple pictures here. All right, now, strong or weak? Strong. Positive or negative? Correlation coefficient is going to be about 1. And really, I should say approximately, because we don't know that it's perfect. Okay? Okay, so, what about that one? Yeah, really strong negative, right? How about that? 0, yeah, no correlation there, right? If I try to put a line of best fit in there, I get a nice straight line. No, okay, there's no correlation between those. Okay, so, like I said, it can be any value between 1 and -1, right? So can we use decimal values? Absolutely. So what if I have something that looks like this? It's positive, yeah. Is it going to be closer to 1 or to 0? It's going to be closer to 1 because it looks like I could put a line through there and still get pretty close to my data values, right? So let's say this is about, I don't know, 0.75. And it doesn't have to be perfect. You're just going to guesstimate it, okay? All right, so similarly, what do you think? Sure, -0.75, right? What do you think? Positive what? Yeah, 0.25, sure. It actually looks pretty weak, right? It doesn't look like a real strong correlation. It looks rather weak, closer to 0 than it is to 1. Okay, so you're more comfortable with correlation? Is any of this coming back to you? Awesome. Okay, so your homework tonight is in your packet, and I want you to take that out. I want to go over a couple of things with you, just so you know how to do these problems specifically. Yes, your homework packet. And I want you to go to page 20 to start. Okay. Don't forget you do have a quiz tomorrow. First 2 questions are rational equations. Third question is an inverse variation. And fourth question is a linear regression. Okay, there's only 4 questions. Yes. Okay, so the linear regression that we came up with in your notes, the table was already in there for you, and so was the scatter plot, right? But you guys have to be able to know how to do that stuff on your own without it being given to you, okay? So the first thing you're pretty much going to do every single time you see a table is to put it in your calculator, all right? So here's the issue with tables. When you have more than one table or scatter plot in a document, sometimes they get mishmashed and they don't like to play nice with one another. So when you're entering in tables or scatter plots, it's important that you start a new document each time, okay? So save whatever you have on your calculator by hitting Control-S. Go home and add a new document. Okay, so what is it that I'm going to insert here? List and spreadsheet. You want to put that table in first, right? What is the A column going to be called? X. Very good. And we're going to go right down to where cell 1 is. Don't type into that gray box. Okay, cell 1. And we're going to put in our info. Remember that each time you have to hit enter. If you don't hit enter after each data value, the calculator will not read it. Okay? Hit enter. And then go over to column B. What are you going to call this one? You're going to hit down to get to cell 1. And we put in our data values there. 26, 17, 12, and 4. Okay. Now what? New page. What are you going to insert? Good. So Control I, add data and statistics. Okay. Does this have any rhyme or reason? Good. We have to click to add our variables. Our domain was X, and our range was, and you notice I'm calling it domain and range. Get used to that. Okay, domain and range. Domain is X, range is Y. Okay, so now we have my points in there. What do I want? I want the linear regression, so how do I get it? Menu, analyze, regression, show linear. Okay, you guys think you could handle that? All right, that's it. Yes, ma'am. Okay, so I'm going to give you got like 5 minutes, but you get started on that homework, okay? I don't believe in redundancy, so if you're getting it, move on, try something that you're struggling with, okay? And I'm here to help. Good? All right, thank you guys.